With the modernization of science and technology, researchers have developed early warning systems for earthquakes and tsunamis. These systems work by interpreting seismic waves, the primary and secondary waves. The primary wave, which is the longitudinal and compressional wave, are the first types of waves that reach land in the event of an earthquake. Since any material is subject to compression, these waves can travel through any kind of material. In water, the average speed of the P wave is about 1450 meters per second. For solid materials, the speed of a P wave varies on the elasticity and density of the material. Secondary waves are transverse waves which involve movement of the ground perpendicular to the velocity of propagation. They can only travel through solid rock. S waves travel typically 60% slower than the speed of P waves. They are, however, typically more damaging than the P waves since they are several times higher in amplitude. Using P wave information, we can estimate the location and magnitude of an earthquake. We use this to estimate the anticipated ground shaking across the region to be affected. This information provides warning before the arrival of the S wave. However, can these waves provide enough warning time for evacuation? The answer depends on how far a particular location is from the earthquake's epicenter. Locations close to the earthquake epicenter that are within the blind zone will receive no warning. Locations far from the earthquake epicenter would receive lots of warning time. For locations in between, the warning time could range from seconds to minutes. A lot of countries are now acquiring the Deep Ocean Detection Buoy system. An undersea earthquake causes disturbance to both the seafloor and the body of the ocean above it. Any resulting tsunamis are then verified by sea level monitoring stations and deep ocean buoys. The seismic monitoring stations can determine the location and depth of earthquakes that have the potential to cause a tsunami. The amount of time between the seismic waves on a seismogram can't tell in what direction the earthquake was. Scientists use a method called triangulation to determine exactly where the earthquake was. If you draw a circle on a map around 3 different seismographs, where the radius is the distance from its station to the earthquake, the intersection of those 3 circles is the epicenter.